Okay, now we are going to do some calculations with simple harmonic motion. Uh, okay, so what causes an oscillator to move? If we, for example, if we consider this mesh spring system, and this mesh is we displace to the left and release it, so this mesh will oscillate. But what caused this mesh to oscillate? All right, so we'll go to this animation here. Okay, so we displace this mesh to the right, and you see this arrow representing force on this mesh. Okay, so when you displace to the right, the force from the spring will act on this mesh, and when we release it, this force will bring this mesh to the center, and when the spring compress, it exerts force on mesh to the right, and it will continue to oscillate. That means force from the spring cause the mesh to oscillate, and it will always bring the mesh to the equilibrium point. Okay, so what is the relation between the displacement and this force? All right, so this what's the relation? So when you see this force, which is represented by the arrow here, when the mass is to the left, the force is to the right, right? And then if the mass to the right, the force is to the left. That means the force by the spring on the mass, they act on the opposite direction. Force and displacements, they are in opposite direction. That is the first thing about the direction. How about the magnitude? All right, so when x, so in here, okay, so when you see when the mass is to the right, that means when x become larger, the force also become larger, right? And then when you when the displacement is minimum, the force is also minimum. So what can you say about the magnitude of both displacement and force? When the displacement become large, the force also become large. So we can make a mathematical relation like this. That means okay, so you have a mass and spring. So when you have a when you displace it to the right like this, force from the spring will be to the left, but it's become large. So you can say that the force by the spring on the mass is proportional by the displacement in opposite direction. So you have two ideas in these relations. So when the displacement is large, the force is also large, but in opposite direction. Okay, so so this force inside the system, the force acts by this spring is called a restoring force. Restoring force. So this restoring force always restore the system into the equilibrium point. So the restoring force, when the object, when the mass go to the right, the force restore it to the equilibrium point, and if the mass is to the left, the force is restore again to the equilibrium point. So that is the function of this restoring force. So since this is our mathematical expression, we can make a statement that the force is proportional to negative displacement, and we can make an equation from it. We can make it as F equal to negative kx. So this is a proportionality constant K, and it is called spring constant, and some book call it as a force constant, and some book they call it as a stiffness. Okay, so how strong the spring is. So this relation is called a Hooke's law. Hooke's law. Okay, F is equal to negative Kx. Force, restoring force, equal to negative K is a proportional constant, and X is displacement of a spring. Okay, displacement. So either in this direction, and there is a force on the object. Okay, so the object undergoing simple harmonic motion is called simple harmonic oscillator. Alright, so if you remember from your previous lesson in mechanics, you have learned about many kinds of motion. Whereas the first thing that you learn is linear motion, right? Linear motion. And then you proceed to the projectile motion. And then you learn about the circular motion. That means something which is moved in a circle. And then you proceed to the rotational motion. Rotational motion. That means for circular motion, for example, you have we have a sun and Earth. It is circulating around. That is circular motion, and the Earth itself rotates on its axis. That is a rotational motion. So all of them they have a special characteristics. All right. So for an object which moves with a simple harmonic motion, which is like this, so you can see that the position is always changed with time. So the graph is like this. So this kind of motion, we call it as a simple harmonic motion. Okay, simple harmonic motion. So it has a periodicity of a motion. So that periodicity is the special feature of the simple harmonic motion. Okay, so the object which is undergoing simple harmonic motion is called simple harmonic oscillator. Okay, pengayun harmonik ringkas, oscillator. For example, projectile motion, the object which is undergoing projectile motion is called a projectile. So a ball, if you kick a ball and the ball is undergoing simple projectile motion, we call the ball as a projectile. For a simple harmonic motion, we call the object which is performing the simple harmonic motion is called simple harmonic oscillator. Okay, so keep in mind that not all oscillator is a simple harmonic oscillator, because the motion condition for simple harmonic oscillator is it must fulfill Hooke's law. So all simple harmonic must fulfill Hooke's law. For example,